Super. There, thank you. So that you just noticed, this symposium is being recorded. We're going to make the recordings available at the Software Preservation Network's website at a later time after the symposium. At the end of the symposium, we'll also be posting all of our documents and presentations in the shared Google Drive that everybody has access to. And as I mentioned before, please make a note of some of those little bit links there because they can be quite useful throughout the morning. And because it has the links to things like attendance list, today's schedule, and the master deck. We're also using the shared notes document as a place to record our discussions and questions. This is a document for all attendees, so please feel free to record any questions in this document that you may have during each of the section of our half-day event. And we'll do our best to circle back at the end of each section and attempt to address as many questions as we have. And everyone should sort of see the agenda here that we have for today's meeting. The focus for today's discussion is software preservation with a focus on 3 of Stanford's emulation use cases. This is part of a larger effort of Stanford libraries to pilot emulation as a possible preservation and access solution for complex digital objects. These are digital objects that are reliant on software and or legacy hardware in order to run. This symposium is an opportunity for us to discuss how the Stanford team has begun testing emulation and engage the larger Stanford community as well as members of the local library, museum, and archives community. We're trying to answer, is emulation a technology that would benefit the research community of our university? And we've invited you to join us because we need your questions and insights as we evaluate the interest in this technology and consider the implications of making it a production service. So on that note, I think it's time to sort of do some introductions. I've already mentioned my name is Michael Olson. I'm one of your hosts here. My pronouns are he, him, and his. One of the first software titles I remember is using Zork 2 on Apple Plus. And the way we should probably work this is I'm going to call on the next person to introduce themselves, and if they could just grab somebody from the attendees list, and we'll do our best to make sure that we get everybody to very quickly announce who they are, what your pronouns are, and what your first computer program was. So Bob, would you be willing to start us off? Jasmine, would you be willing to say hello?
Yes, hello. I'm Jasmine Mulliken. I'm at Stanford University Press, and the first software I remember using was a print shop program on Tandy 2000. How about Kris?
Great. Hi, everyone. I'm Kris Kasianovitz. I'm a government information librarian at Stanford's library. My pronouns are she, her, hers. And the first software program I remember using, I had a homemade built DOS box, and I think it was a really old version of WordPerfect. So good memories with a dot matrix printer to type all my papers. Okay, I'm going to call on Ron next.
Morning. This is Ron Nakao. He, his, him. The first software I remember using was two programs, Mac Write and Mac Picture, on the first Macintosh that I got, 128K. And I will call Bob. Are you ready?
Yes. Sorry for the mute. Bob Stein. The first program I used was a Bally Arcade in 1979. Who's next? Who hasn't gone? Jasmine, have you gone?
Yes, I have.
Okay. Abby.
Sure. Hi, my name is Abby Chen, and then I work at the Stanford Business Library. And I remember the first operating system is Windows 3.1 for me, and then the first program I used is to be WordPerfect. I was just typing in the document. That's it. Annie.
Hi, my name is Annie Schweikert, pronouns she, her. I'm a digital archivist at Stanford, and the first software I remember using is Oregon Trail, and the first computer I used was the translucent iMac that came in a bunch of colors. I don't remember what type that is, but I remember what it looked like. How about Ethan? G3, says Ethan.
Hi, I'm Ethan Gates, he, him, his, and software preservation analyst at Yale University Library and for the EASY team. And my first memory is playing original Where in the World is Carmen Sandiego on the Family Macintosh Plus. Jessica.
Hello, my name is Jessica Meyerson. I'm a member of the EASY program of work also, and I am the Director for Research and Strategy at Educopia Institute. I have very fond memories of playing with really early versions of Adobe Photoshop on, and I forget the model name, but we had a Sony PC, and this was also around the same time that I was logging on to America Online Instant Messenger chat a lot. So yeah, those two, chatting and playing with Photoshop to create photo collages, are two software memories that are closely coupled. Let's see, Michael?
Hi, you mean this Michael, right?
Yes, you.
There's so many Michaels in the world. My name is Michael Cohen. My pronouns are he, they, it, choose what you will. I'm currently a freelance tech writer. Once upon a time, I worked at the Voyager company. My first computer, I guess it was an IBM 36091, and it was the quick run batch processor when I was learning COBOL back in the late 70s. It was fun. Let's see, do I pick the next person? I don't know who to pick. Regina, have you gone?
Okay, no, I have not. Hi, everyone. I'm Regina Roberts. I'm a collection development librarian at Stanford, she, her, hers. And the first computer program that I remember using is Xywrite, and I was using it in the computer lab at my college undergrad. So let's see, who's next? Oh, Katie Boss, thanks for joining us.
Yeah, of course. What a fun icebreaker question. And it's good to see. I can start my video. I don't know. I have been racking my brain while everybody else has been doing their introductions to be like, what was that computer that we had in the 80s? And I don't know what it was. It was something like that my dad brought home one day. And I just have very fond memories of our WordPerfect and our dot matrix printer. And oh, my pronouns are she, her, hers. And let me see, who can I pass it to? Ilya? Ilya, are you ready?
Hi. Yes. Hi, everyone. I'm Ilya Kramer. I work on the Web Recorder project and also collaborating with Stanford University Press on some work. And the first program I think I remember using was probably Oregon Trail on the Apple IIe, if I'm remembering that correctly. It was either that or Number Munchers. And let's see, who else pick? Hannah.
Hey everybody, my name is Hannah Frost at Stanford Libraries, she, her. I have no idea what the name of the program was. I just remember doing math on a computer, an Apple, in the math lab at my school, probably in 1981 or 2. So yeah, math. I'm gonna pick Arcadia.
Hello, I'm Arcadia Falconi. I'm the metadata coordinator at Stanford Libraries, she, her, hers. And the first software program I remember using is WordStar. Dinah, why don't you go next?
Hi, my name's Dinah, she, hers. I work at Stanford University as the Digitization Services Manager. +1 to everybody who's within my age range, like generation for the G3 and that's a formative computer for me. I was thinking about KidPix, which I spent a lot of time playing with in my mom's classroom after school while she worked, and yeah, made a lot of art on KidPix. I choose, hold on, Josh. I choose Josh.
Josh Schneider, University Archivist at Stanford, he, him. Bringing up so many great memories. I guess I remember calling into like bulletin boards and Prodigy, like early getting online. And then I distinctly remember being a triangle in my like math lab and needing to get to another part of the screen and entering coordinates. I think it was Logo. So that was a pretty sweet memory. Very formative. I joined late, so I don't know everybody that's gone, but I will call on Sally if she hasn't gone.
No, thanks, Josh. I joined a little late too. I'm Sally. I am a digital archivist and the EPAD project manager at Stanford, she, hers. And the first thing I really remember doing was playing this game called Caesar 3, which was like Sim City, but set in ancient Rome, and it was so fun. I would love to play it again. Okay, let me see. Actually, I have no idea who hasn't gone, so if someone could help me out.
You want to go?
Thanks.
Who did you say to go?
We have Amy Hodge or...
Oh, yeah.
Go ahead, Amy.
I can go. You just cut out on me right when you said that. I'm Amy Hodge. I'm the Science Data Librarian at Stanford Libraries. She, her. And I'm having a hard time pulling out an actual like real software program, but the first computer use that I can recall was in elementary school. We typed in programs in BASIC to draw squares on the screen, and that was on a TRS-80. Which stands for the Radio Shack. If everybody's used a Radio Shack computer, but I don't know who had all these Macs. Not where I live. No one had a Mac. That's too fancy and expensive. So we had TRS-80s. And I will choose Andrew.
Hi, I'm Andrew Berger. I'm repository manager at Stanford, and I don't remember what it was, but I remember when I was very small connecting to my dad's work, which was on a mainframe, and playing games like tic-tac-toe, but not global thermonuclear war. Probably wasn't a good idea to let kids access that machine, but we did. I will call Christina.
Hi, my name is Christina Fiddler. I'm the digital archivist at the Bancroft Library at UC Berkeley. I use she, her, hers pronouns. And I think the first program I can remember has to be Oregon Trail, if not Carmen Sandiego. I was very addicted to the original Carmen Sandiego and know all the country's flags as a result. Really fun. So I will choose, I'll choose Mary.
Okay, thanks, Christina. This is Mary Ailings. I'm the Assistant Director of the Bancroft Library and Head of Technical Services there. My pronouns are she, her, hers. I think my first computer was an Apple II. And let's see, besides a word processor, actually the first real kind of program I remember working with was HyperCard, which was a kind of almost like an early database program. So that was me. And
yeah, I'm just going to jump in here really quickly just to sort of speed us along really quick. Kate, do you want to go?
Sure. I'm Kate Barron. I'm the research data curation librarian at Stanford University. My pronouns are she, her, hers. And I don't remember what it was called, but I played like a gardening simulator on Windows 95, and that's the first kind of software I remember using.
Thank you, Kate. How about Greta?
Hi, I'm Greta DeGroat, metadata librarian at Stanford University Libraries. And I think the first time I touched a computer was at Lawrence Hall of Science, where they had a mainframe running ELIZA, which you could access with a little printer and ask it questions. And that's the first computer experience I have, and didn't become an active user of computers for like another decade. That had to be around like 1977 or so.
Great, thanks, Greta. Jeff.
Hi, Jeff Willard, Media Production Coordinator at Stanford. He, him, his, I guess I'm showing my age along with everybody else here who's going to say Oregon Trail. Also on an Apple IIe, I'm probably around 89 or 90, something like that.
Great, thanks, Jeff. Glenn.
Hi, this is Glenn Edwards, Assistant Director in Special Collections at Stanford. And the first thing I remember using is WordPerfect.
Thank you, Glenn. Hanson, can you please say hello?
Hi, yeah, my name is Hanson. I'm the software curator at the Computer History Museum and Center for Software History. And first program I used, it was probably some educational software on the Apple IIe at school. I don't remember exactly which that was. I was probably in second grade. First home computer we had was a Mac Plus. And I remember my mom teaching me to using the demo that ran on that computer when you first booted it up. I would teach you how to use the mouse and how to like move around with like drag menus and stuff. The first program I wrote was probably a hypercard stack script. Yeah. I guess I'll choose Henry Lowood.
Hi, I'm Henry Lowood. I'm the curator for History of Science and Technology Collections and Film and Media Collections at Stanford. The earliest software I remember using was Fortran 4 with the Waterloo compiler as a freshman engineering student at UCLA.
Thanks, Henry. Lauren, do you want to say hello?
Yeah, hi everyone. I'll turn on my camera here briefly. I'm Lauren Work. I'm the Digital Preservation Librarian at the University of Virginia, fellow Easy Node here supporting you all in this online symposium. My pronouns are she, her, hers. And the first computer, like a lot of folks, was a Mac 2. And I remember spending a lot of time playing the preloaded games on there, including Dark Castle, if anybody remembers that. Yeah.
Great, thank you. Michael Angeletti.
Hi, my name is Michael Angeletti, and I am a moving image digitization specialist at the Stanford Media Preservation Lab. He, him, his. Like Amy, the first program I remember using was probably something on a Tandy TRS-80 around 1985. Probably just playing around with BASIC, or probably an arcade-style game like Othello or Blockade.
Thank you, Michael. Patricia Franks. Would you mind saying hello?
Hi, yes, I'm pleased to say hello. I'm Pat Franks, MAR Program Coordinator from San Jose State University in the iSchool. And although I can remember starting out on the TRS-80 Radio Shack, the system I was most excited about, I don't know if you remember, was an IBM desktop publishing with PageMaker, and it all came at once. So you had to buy the computer with the printer and the software all together. And I think at that time it was almost $10,000. It was quite interesting, and it's great to see where we've come since then.
Great.
And it's a she, hers.
Peter.
Yes, Peter Chan, did web archivist at Stanford University, and him. The first computer I used is a Fortran compiler run under DEC 20.
Thanks, Peter. Spencer.
Hi, my name is Spencer Gondorf. I'm the assistant curator to Silicon Valley Archives at Stanford University. My pronouns are he, him, and his. And I was having trouble thinking about what the first program I played on a computer was, or even what the computer was itself. But I remember in elementary school being in the computer lab and spending hours playing Oregon Trail. So I'm going to go with that one.
Wonderful, thank you. Suzette.
Hi, I'm Suzette Cañeta. I'm the Acquisitions, Efficiencies, and Technology Librarian at Stanford. First program I remember using is, I'm gonna say it's either Oregon Trail or Carmen San Diego.
Wonderful. Well, thank you, everybody. Is there anybody that we've missed? Feel free to jump in right now.
Colin. Can you hear me? Is my sound working?
Yes.
Okay. I'm Colin Holgate. This is like the world's longest game of Russian roulette for me. I'm the last bullet. As with Michael Cohen, I worked at Voyager for many years, and Bob's going to be showing some of the stuff we did. My first computer use was of a program I wrote myself on an Apple II Plus in 1980. So I predate Carmine, San Diego, and the other ones.
Super, thank you, Colin. My apologies for forgetting you. So we're going to move on now. We're actually, the team, the host team here has decided what we're going to start with the International Monetary Fund, one of our use cases to sort of illustrate what we're talking about here. So Kris, do you want to take it away?
All right, hang on. Here we are. Okay, yay. It looks like it's loading, and you can all see that, hopefully. Hi, everybody. Kris again. So we're kicking off before we dive into all of the great information about as a service project with a use case, just to kind of set the stage for what we've been working on. So Ron and I are actually, with Michael, are going to give you some background on the IMF data that we're working with and then do a demo. So we are talking about a pretty common use case. Everyone has used CD-ROMs. You've probably cataloged them, Greta and Arcadia. So we've all got these in our collections and libraries. And the International Monetary Fund is one of the prominent producers, gatherers of economic data and data about global finance and economies. And so they've been producing time series data since the 1970s. And so initially this was produced in print. Then they moved into the era of CDs and being able to make their data available in a database format that could be queried and you could extract data. So libraries receive these as CDs. And I should point out, these are not unique in any way, shape, or form. In fact, most libraries across the globe will have them, but this is primary research data. Why was it important to bring this to the EASY program to work on? Is because we know that over time, variables get revised in these data sets. The IMF moved their data online, fully online, about 4 years ago, and they were not able to include all of the vintage data. So there's issues of data revision as well as lack of access to historical data. So with us being able to utilize the EASY platform, we're able to basically unlock the historic data for researchers. And then usually it's faculty and graduate students who are needing to access this, the older vintage data. Oftentimes they've found it cited in an article and they want to track back to that original data because they may find that when they go to the online, it's either not available or in some cases, the numbers aren't matching up. So what we're able to do here is basically unlock that data. I should also point out that the US federal government, there's something called the Federal Depository Library Program. They have had a floppy disk project, which has moved into a CD-ROM project. And so this will actually be the first foray into international statistics, which I think as a GovDocs librarian is pretty awesome. And I can't wait to tell the entire GovInfo community about this once we're able to go into production. Okay, so we're gonna move into a live demo. I'm gonna hand it over to Ron and Michael. Go for it.
Okay. Thank you, Kris. Can folks see my screen?
Yes.
Yes.
Super. Okay, well, what I'm going to demonstrate here is this is, we've actually, we're working off of CD-ROMs here. So what we've already done is we've already created an ISO, a preservation package of that CD-ROM. We've taken the data off of it. And what I've actually done is I've associated that CD-ROM installer with an operating system. In this case, we're looking at Windows XP plus Adobe Acrobat Reader 9.3. So I've already associated it. And what I'm actually going to show you here now is how we're going to install the program. This is a one-time process of doing the install because we'll save the environment. But I just wanted to show folks what it looks like. You get to actually work in the old Windows XP environment. We also have networking currently turned off on this just because on the Stanford network, if we're running a networked XP instance, our IT security will let us know that we're running an old operating system that is no longer supported. So it's not kosher. So we're just quickly going through the install here. And as I said, this is a one-time process. So what we're going to do is we're installing this application and we're just going to save it and shut it down. And just make sure it works. Okay, yay, it runs. Now I'm just going to show how we would save the state. We need to properly shut down the operating system after I've done the install. And then we'd essentially would save Windows XP plus the installed GFS browser, which is the IMF data in this case. And once it is shut down, we can actually name it. So So this is essentially just keeping track of the stack that I've actually already installed. And then I would click and save it. I'm actually not going to save it at this point. And Ron, do you want to maybe take over and actually show folks a little bit about what the GFS actually is?
Sure, Michael, thanks a lot. Let me, why don't you go ahead and, did you unshare or should I just?
I've unshared.
Okay.
So you should be able to share now.
Okay, and. Okay, Can people see my screen?
It's good.
Yes.
Okay. So as you saw, Michael basically took you through the steps within the EASY framework to actually create an emulated system that included the necessary version of the operating system and any other software or other objects, digital objects that needed to be imported and saved in that environment. So what I'm going to do is go ahead and start up the environment. And so you can see here, I've clicked on the environment screen and clicked on the objects. And I'm going to select this object and run it. And then we'll all get to view the beautiful beginning of Windows XP, which we probably all missed. It is a security hazard for folks, and often you can't even run it anymore since it's not supported. One thing that you'll notice is this is an emulation, so often things tend to lag a little bit, or they tend to be a little slower than you might be used to if it was running natively on your own computer. I still haven't come across, fortunately, the blue screen of death yet, but that might be an earlier version of Windows if we run things needing that.
You sound like you're missing it, Ron.
Yeah. Yeah, that was it was kind of one of those moments in the past. Okay, so now we see we have the screen here, and I'm going to go to the GFS browser, which was installed, and a shortcut was installed on the desktop. And for those who haven't seen the wondrous CD-ROM-based application for browsing and extracting time series data from the IMF's government finance statistics, this is basically the working application. So as you can see everything that you would see if you were on a computer. And so the first thing that often you will do, because you want to define the retrieval period that you want to use to actually do your search. So in this case, because this is the 2012 version of the IMF CD-ROM, and I know that that particular CD-ROM only has data from about 1990 to around 2011 or so. I'm going to go ahead and constrain the retrieval period to those years. The other thing that you'll see is the GFS, the working navigation screen here, and you can, within the GFS browser, you can actually view any of the documentation they have here as a PDF file, and that's why Adobe Acrobat 9.3 had to be installed, because you have to use something that can read the kinds of stuff that bundled with that software. So you can go ahead and read through any of the documentation that accompanies it. Kris and I had been talking about at some point, we would also want to identify other documents and stuff that would be useful for the user. And then I'm going to go down and actually go up here to the options, because the options is another thing that a user would do to kind of customize their search interface. So let's say, rather than getting every single country when I'm looking at time series data, let's say I want to basically just restrict my searches to Canada and the United States. So basically I would do the classic control click and set the constraints. And now you see it's restricted now when I search or browse to Canada or the United States. I also would like my time series data to be grouped by concept and not by country. And since I want to do more of a panel thing with the data, I want it to be such that each row of the data comes out as a year in the thing. And then I might want to see the data source also and other metadata that's here. And so I will go ahead and click the browse again. And I'm going to go ahead and show you how you would use the economic concept view, because one of the advantages of that view in this data set is it actually tries to harmonize the time series data between different countries, and you can actually choose more than one country when you're searching it. So I'm just going to choose something just to show you how you extract something. I'm going to go ahead and take revenue. As you can see, the country pane only has the 2 countries that did the search. And this is the listing of all the time series files that come up for the 2 countries. Each GFS time series data has a unique code for each of those tables or time series that are displayed. So I am going to basically say, let's get revenue, control click taxes, and let's say corporations and individuals. Okay, and one thing I can do is I can actually check to see the availability, because not every country in the GFS time series has data for every variable in the time series. So you can see here that in the availability table, Canada and United States, each table is a column, and it shows you with an X if it actually has data for that. So you can see for Canada, it doesn't have anything in the last 2. So I think what I'll do is I will basically not select those 2. So what I will do now is select those 2 time series. I'll select the 2 countries I want to extract data from all the time series that the GFS database has, and then I'm going to add it as series that I want to retrieve. And now you can see down at the bottom, these are the 4 time series, 2 for Canada, 2 for the United States, that are ready to be retrieved. So when I'm ready, then I will basically click the retrieve button. It will do a query to the Microsoft Access database. And now you can see this is the actual data that was extracted that I can take a look at to see if it looks fine. You can see it contains a lot of the metadata that was checked in the options column. So I can see which country, the units of measure, and information like that, the description of what these different time series are, and the actual numbers and the units of measure for those time series numbers. And so if I say, okay, I think I want that, I can actually go to the file in the data viewer. This is not the browser anymore. Save as. And it will save it in my documents. I'll just call this test. And let's say I'm going to save it as an Excel 97 file, because I want the most modern version of Excel for this data to be saved in. And now it should be saved. So now I'm going to just close the data view. And I think that basically takes you through a lot of what a user would do if they could actually access these historic CD-ROMs in the emulation environment. So I'm going to go ahead and close this. And I basically created a shortcut for my documents on the desktop. So I'm going to open that up. And you can see that my test data is actually there. There's other files that we would probably, or shortcuts or other information documents we'd want to put on that desktop as we really tried to make it more user friendly and usable. So as Michael said, once you finish, then you go to the start menu and you turn off the computer. And one thing that you'll learn is you generally, if your cursor is trapped in the emulation window, you can click the escape key and it will be released. So now Windows is logging off. And we can go ahead and just, the emulator has been stopped. So I'm going to bring up the last slide if I can get to it in our presentation. Can everybody see that?
Yes.
Challenges stability in a production environment. So Kris and I kind of, through our playing with this and stuff, and also thinking about how we would want to eventually serve the IMF databases, came up with some different kinds of issues or things that we found along the way. And so I'll go ahead and read through them, and Kris, you can go ahead and weigh in at any point. The first thing was
Ron, Regina actually asked a question, which is our first bullet point. So Regina, I'll just point out, you asked if we could extract the data. And as you can see, exporting the data and the docs out of the easy environment isn't yet possible.
Okay, thank you. And also, if anyone else has questions, please feel free to either type in the chat or on the shared document.
The other thing is what Kris had referred to when she kicked off our section was, we need to think about other kinds of documentations, whether that we might want to include manuals, methods, related print publications. So in a sense, it's trying to curate this whole environment with the object that we want to share in the emulation environment. As you probably saw, it wasn't as bad as usual. Often I blame it on my very slow home network speed, but often I would get an erratic cursor or scrolling or other behavior wouldn't work. At one point when I was trying to open a folder or something on the desktop, I could not open it. I'd have to right click it and then select open from there. Otherwise I would get the little window, pop-up window to set the properties for that particular document. So there's little idiosyncrasies that we still need to work through and try to see, how robust it is for the user in different environments. The slow processing speed of the emulator, it's something that we've all experienced when we've run things like Fusion and stuff on our own software, because emulation is not running necessarily natively, on the hardware. A full screen in Windows, hopefully people were able to see it, but you're kind of constrained within the environment to the extent with which the window will go. So I would, at one point I had opened a big PDF file that had larger font, and I couldn't read it all the way across because it filled up the entire screen that was available to me. Keyboard match, I noticed that, for example, on my Mac extended keyboard, my page down and page up buttons wouldn't work in the Windows environment. So it's just another little things to think about for all of our users. Are the operating system requirements the same across all CDs? This is something that we, will continue to investigate, especially as we, load more years of the IMF for different products. And Kris, you want to talk about the rights issue?
Sure. So we've been talking with the IMF folks, letting them know that we've been working on this project. And one thing we have to be cognizant of across any software environments is our rights issues, either with the software or with the content of the software. So in our case, the data is open. The IMF has released all of their data. It's publicly available, so we don't have an issue with rights with the actual data itself. But there is an issue that we're going to have to investigate. Is the IMF contracted with a third party to write that UI that you saw Ron working with, and it's unclear from the IMF standpoint whether or not they assert any type of right over that. And so that's just going to be something before we can kind of open this broadly. We have to make sure that we've gotten the correct permissions if needed, or at least a sign off from the company that we can, make this available. I think the risk is fairly low in terms of someone trying to copy that user interface because it is so antiquated, but it is an issue that we will have to be mindful of.
Yeah, and I want to just raise that Ethan gave us all little tantalizing things for the future, because this is still kind of in development, but a future version of the easy environment will be able to do data export. So I think especially for data CD-ROMs, that's crucial, because otherwise the user, what's the use? You go in there, you extract your data, and then you can't take it out to your own computer to actually do your analysis with it. So unless we provide all of the analytical tools also in the old environment, it's something that might be cool to look at, but it won't really help our users. So at that point, I think we'll go ahead and hand it off to Ethan, And if there's any questions, you can always email or put in the chat box or email afterwards or talk to Kris and I about the IMF in particular. So thank you. Oh,
yeah,
go ahead.
Before we do that, I just want to mention that Michael Cohen had entered something in the chat about the issue of non-English keyboards and non-Roman character entry. So I guess that's something that's under development or that needs to be thought through. And Ethan has responded. So I don't know, Ethan, if you want to talk about that a little bit before we.
Just briefly, I mean,
Okay.
all of these points absolutely have been like taken into account in guiding the future development. And you know, as I'll get into in my presentation, I mean, so many of these things are absolutely technically possible, like selecting a different keyboard and passing the input, sending different, you know, more sophisticated combinations of keys like page down, page up buttons. And it's just a matter of, you know, polish and scaling you know, the platform and making sure the quality assurance is there. So I mean, but this is the point, was to get this in what we have in front of you all, so that you would give us that feedback about what the platform needs to do. So that seems a good transition into my section. If anyone,
Great, yeah.
And now I'm going to stop sharing so you take over, Ethan.
Awesome, thank you. One moment. All right, can you all see my screen?
Yes.
Yes.
The reservation slide. Awesome. So thanks everyone. I'm really happy and excited that the Stanford team asked me here today on behalf of the EASY team to talk to you all a bit more about our program of work and basically how what we do and how you know, the demo that Ron and Michael just showed you is possible. And I'm also really glad that we kind of kicked things off with this IMF use case in particular, because it's a really good entry point into us considering, you know, the broader implications for software-dependent data in the field of digital preservation, sort of the wider problems that this leads us to. You know, you can see the challenge of both preserving the content in those IMF CD-ROMs, so the data sets themselves and the variables, but also the context, you know, the fact that they were distributed and interacted with as CD-ROMs in a Windows XP environment or possibly even earlier matters when we're talking about scholarly research. And you know, we all know the pace of technological change means that files, formats, fonts, software, hardware, peripherals, etc. Things, computing pieces from even 5 years ago are no longer supported or accessible, much less as we've gotten into 10, 20, 30, 40 years, as we've heard in all of our wonderful opening icebreaker questions. So when we talk about digital collections and content coming from those different eras of computing, converting or migrating that content, you know, is it even possible is a big question. And even if you manage, you know, in the process of converting the content into something that is usable in a contemporary computing environment, is the context preserved? Do they actually render as they were intended to be seen, even if the bits and the bytes, the zeros and ones are all still there? Is that actually what, is that translating to what the user is seeing and accessing? What about the aesthetic and the form of interaction? What about, you know, just all these questions of how are we delivering digital collections to patrons? These are the kinds of questions that we're obsessed with in the Software Preservation Network and in the EASY project. So I do want to kind of back up for a minute here and take a little time to get everyone on the same page when, you know, when we talk about software preservation and we talk about emulation, what do we talk about? So when we say, again, in software preservation network land, when we say software preservation, we're talking about policies and procedures for the collection, description, and maintenance of files and information necessary to operate software for the purpose of study or to provide access to digital objects. What that basically boils down to is developing a framework for treating software as itself an object of preservation, you know, elevating source code, executables, applications to the same level of preservation and care that we do with general digital collection materials, you know, the PDFs, the text files, the office files that were photos, et cetera, that we're kind of used to dealing with in the digital preservation world. You know, what exactly, when you treat software as a collection, what do you have to document? How can it be used, and by whom, in what contexts, in a library or an archive context? What dependencies are critical? Like, how can it actually be run? It's very difficult when you're talking about software as preservation object to keep in mind that the raw materials of software isn't necessarily enough to make software understandable or usable by a future user. Unfortunately, unlike just a plain text file, you can't just open it and necessarily get the same interaction that was originally intended when you try to run a .exe that was originally intended for Windows 3.1.1. Preserving those bits, again, bytes again, is just one piece of the puzzle when we're talking about something that's meant to be executed or operated. So how do we operate legacy software on our current contemporary computing setups when there are issues with system compatibility? You know, programs that were written for a specific operating system or CPU architecture, when they are dependent on obsolete software libraries that you might not have access to anymore, when they are dependent on security features. So, you know, if you've ever tried to access a you know, really old website on a modern browser that you know, or I should say, when old browsers try to access contemporary web material is the more likely scenario for this case to come up, and they don't understand contemporary HTTPS security protocols and the site breaks. It's all a matter of trying to provide functioning manifestations of software that support access as it was intended. And this is where emulation comes in. So emulation, which again, many people, if they've heard about it coming into these discussions with the EASY program, have probably encountered it in the context of video games and playing consoles on your desktop, et cetera. But it's a really broadly applicable term in computing, which just refers to using software, the use of software or recreating computer hardware and operating, sorry, the use of software to recreate computer hardware and operate computer systems and legacy software on host infrastructure. So again, broadly speaking, when I try to explain what I do to family or friends, it's about, I'm trying to run old computers on newer computers, which is a bit simplistic, but it usually gets people there. The idea is that an emulator, which is itself another piece of software, which is a whole other sort of rabbit hole to get into. Using an emulator, you can mimic the functionality of physical computer hardware. And if you combine that with disk images, and a disk image is a file containing the contents and structure of a disk volume of a physical data storage device. If you use a disk image then to recreate storage components, yeah, so a hard drive, a USB, a CD-ROM that has data on it, we can mix and match these two things together and actually recreate legacy computing environments. So just to visualize again what I'm talking about here and put it in a emulation as a service easy context. If you consider the physical computing environment that's in front of you right now, your own laptop, it's a combination of hardware, right? A keyboard, mouse, touchpad, screen, a RAM, a processor, et cetera. All these, you know, hunks of plastic and metal and circuitry that come together to execute the directions given to it by software. You have some sort of bootable system. So that would be your either a hard drive on a desktop, increasingly solid state drives on your laptops, but the storage device that contains your operating system, file system, drivers, applications, the things that just sort of come with your computer from go, the things that again are required to make it work. And onto which you generally load additional software or content, right? On flash drives, on external hard drives, floppies, CD-ROMs. That's additional software or content, more applications, more personal files. So if we think about moving from the physical environment into an emulated or a virtual environment, what does that actually mean? We break this down into the same basic categories of components, but basically the emulator is what is going to take care of all the hardware pieces for you. So the emulator recreates hardware components, and then we have various kinds of disk image that will handle either your system drive, again, that has your operating system and applications on it, and then as we saw with the IMF disks, you might create some like ISO disk image files that recreate the experience of loading in additional content on a physical storage device. And you put all these things and combine them together, and you get what we call an emulation environment. If you're familiar in general with the concept of a virtual machine or a VM, you may have run into that concept elsewhere. We are essentially talking about the same thing here. You could easily refer to one of our easy environments as a virtual machine. We have generally been pushing the term environment instead for our context, just because we feel it's more descriptive of kind of the complex interplay that's happening here between these different components. If you change or shift around any of these one things, either individually or in relation to each other, you've created a unique experience, a unique object. Every one of our computers, every one of our laptops that we're working on right now is a very particular combination, right, of software and hardware, different devices that we're all using. And we're trying to get at, through emulation, preserving that whole context. So depending on the different emulation software you choose, you can recreate a whole different variety of different hardware systems. There are many, if we, again, just think of the history of computing, there are obviously just been many, many companies, many brands, many models of hardware that have been popular for computing. And likewise, there have been many pieces of emulation software developed, often by open source software communities, to recreate that variety of hardware. So just depending on what you choose, you could run Mac System 6 on your Windows 10 machine. You can run Windows 95 on whatever the latest Mac OS is. If you are like me and really like to get into the weeds, you can go back to the 70s and run your Xerox Alto. And if we take this and recreate these systems, we can thereby also take items like the IMF CD-ROMs and run and render digital objects as they were intended for those systems on your contemporary computer. And I would point out at this point that using this technology, using emulators as an access strategy for digital collections, even though it's 2020 now, this is not a new concept. You can go back to, I can point you to several seminal pieces in the mid-90s that discussed emulation as a way forward for providing access to digital archives and digital collections in a library and archives context. But there have been a lot of important advances just in like the last 5 to 10 years that make it really much more of a practical solution in the context of digital archives and cultural heritage institutions, which is what I want to lay out here. So before we even get into the easy project of work, a really kind of important thing to clarify, or a question we get a lot, is what is emulation as a service, EAAS? They're not quite the same thing, and I'm just going to define that here because about 10 years ago, a team of researchers and developers at the University of Freiburg in Germany, as part of a grant project called BWFLA, started this work to address the challenges of how do we take this amazing technology of all these different open source emulators that have been developed by the computing community and leverage them and scale them to the thousands of objects that are often contained at collecting institutions. So the emulation as a service framework, it enables users to, first of all, remotely access emulated environments via a web browser. So this is a great move forward just for access. Obviously, people are going to be more likely to want to access emulated environments over the web than they are to want to come into a reading room where you've set up an emulator locally. emulation as a service also has the benefit of abstracting interaction with some of the technical elements of emulators. They are often very picky to set up on their own. And so the emulation as a service platform sort of works at a higher level and allows users who are maybe not as familiar with the ins and outs of computing hardware and running emulators to focus on just sort of high level decisions like, I mean, just installing an operating system, something that they are more likely used to have done in their just sort of everyday use of computing. The emulation as a service platform also allows access all at once to many emulators or even multiple versions of the same emulator, which can be really great for just, I mean, broad compatibility. Again, when we're talking about consolidating and recreating the very wide range of possible hardware dependencies that you might encounter, you know, again, in a large collecting institution like a Stanford or a Yale, where our digital collections go back decades. Instead of having to sort of separate out your efforts and figure out, oh, I need an Apple II emulator. Oh, I need a Commodore emulator. Oh, I need a PowerPC Mac emulator, and having to go out and follow the instructions for each of those programs individually. You can just pop them all into emulation as a service and just sort of centralize all those different components. And you can then save and return to those as any operating system, any combinations of software that you create using those emulators, you can return to them as persistent emulation environments, as persistent virtual machines, as we've already seen in the demos that Michael and Ron have shown us. And the last really great point kind of to make, since Michael and Ron also brought up saving environments and sort of this process of creating derivatives or snapshots of the work that you did in a session in an emulator via the EAAS platform, is that EAAS allows management of the underlying disk images and derivatives that drive all this work based on sort of compressed and snapshot-based storage, which is just to say that, say in this example that I have pulled up here, let's say you have some statistical analysis code dependent on a particular version of the application SPSS. In this diagram here, every single one, each one of these three different machines is itself, could be its own standalone environment and persistent environment. Even once you've installed SPSS 13, after starting in Windows XP, you installed a program, you saved that as its own derivative, and then you installed code and saved that as another derivative. Each one of those you can return to if we had a different data set that also required SPSS 13, but we didn't want to save it in the same place as our original data set. We could do that. If we wanted to go all the way back to Windows XP and then install Adobe Acrobat or just a completely different program, we could keep returning to the persistent Windows XP environment. But at each stage, we're not recreating the entire base. We're not recreating all of the storage that takes up the Windows XP operating system over and over again, which would quickly obviously fill up our digital repositories, right? If we had to duplicate that data over and over again. So this is just to hype the sort of data storage capabilities of EAAS, in that it takes care of that for you and eliminates a lot of redundancy. So in addition to the EAAS framework and Freiberg's work over the past 10 years, we wanted to highlight that sort of another major move forward that has made emulation and software preservation more possible in a institutional cultural heritage context, was this document developed in 2018 by the Association of Research Libraries in collaboration with the Software Preservation Network, called the Code of Best Practices for Fair Use in Software Preservation. And this is really a legal guidance document to present to administrators, and it was developed under the guidance of a lot of copyright experts taking a look at the problem of proprietary software and copyright in a software context, and whether libraries, archives, museums were justified in their use and possibly distribution of proprietary software, even if it's, you know, abandoned, even if it's old. Were we justified in using old software for the purpose of providing access to legacy digital objects for research? Were we justified in networking that software together and allowing us to share, you know, if I have Adobe Acrobat 9 at Yale, can I give that to Stanford? And all of which is to say you should read the entire document, but we basically got consensus, a critical consensus from the copyright and legal community that yes, this is a fair use under the legal copyright definition of fair use, to much like, you know, Google scanning full copies of books in order to provide snippets for discovery and documentation and access purposes. We can share software amongst ourselves as well. So the easy program of work really wouldn't be possible without that sort of legal and administrative consensus. And if you're interested in diving more into who the document applies to and who fair use in this context applies to, I mean, I really recommend you, again, read the whole document. It's very accessible and readable, even to non-copyright scholars like myself. But to note that there are a few guidelines for who it applies to, and therefore sort of who can join our efforts in the software preservation network and in the EASY program. We're talking about, you know, collections that are routinely made public or open to researchers, collections that were lawfully acquired somewhere by one of us, software, or we're talking about institutions that have a public service mission and have trained staff and you know, volunteers that provide the usual library, archive, museum services. So at that point, I think we have a few minutes before we're right on time. I think I have about 5 minutes. If there's any questions about these sort of like big picture topics that I've addressed so far, I'd be happy to answer those for a few minutes before I think we'll do a quick coffee break. Then I'll come back to talk about more about EASY and exactly what we're doing in the EASY network.
Hi, Ethan. This is Regina. I have a question about the software, sort of in the back end when users are, say they're interacting with the software through, through like a library catalog or something. Would they be able to see how the software interacts, like the back end sort of work that goes into creating the ISOs, or do they just see the emulator and that's it? Can they see both at the same time?
So our general vision for integrating like the IMF CD-ROM environment that you saw, or emulation environments similar, into like a library catalog or into you know, special collections access interface, is usually to abstract as much as possible, which is to say probably the end user, the scholar, the student, whoever you're trying to offer that, you know, data set up to in the end. I mean, our general assumption is in those cases is that they don't care so much about what we're doing on the back end, about the emulator, about what it took to you know, install the specific version of Acrobat necessary to open a PDF from that time period. They just kind of want interaction. But it depends, because we also realize that the context is important, and there very well are also people we've encountered who do want to know those questions, and you know, there are people who are going to need a lot of guidance in how to even interact with legacy software. So we're thinking a lot about how to present supplementary information alongside emulation environments to users and integrate that sort of supplementary information into a library catalog alongside the object in the first place, whether it's, again, help text over, like what Ron showed, like, hey, double click on the shortcut labeled My Documents on the desktop when it boots up in order to get to the thing that you're trying to get to. Or whether it's, hey, here's some background information about what you're seeing and how it actually works, and exposing that a little bit more. But as I say, in general, our assumption is that, it's contextual, but does that answer the question?
Yeah, thank you. Does anyone else have questions for Ethan?
I just wanted to jump in really quickly here and mention that Jessica Meyerson mentioned in the chat that it looks like there's going to be some systematic work and end user studies kind of answering this. So that's important.
Yes, and I'll say, like, as I said, I'll get into with the EASY program of work, we are really about putting the infrastructure in place for people to do all sorts of things for it to implement this technology. So our goal is to build as flexible of a platform built on this technology as possible, from which we can get a lot more sophisticated with how it's targeting certain user communities.
Hi, Ethan. This is Ron. Can you talk a little bit more about the concept of the nodes and collaborative sharing versus individual institutional kind of restricted use, probably touching on the copyright or licensing issues that each institution has, or software restrictions?
Yes, I'll get into it in more detail in the second part of this presentation as well, but I think it's a good thing to point out here that basically one of the major developments that the EASY program of work has sponsored on top of the basic EAAS functionality that I just discussed was to enable the sharing of resources between different installations of EAAS. So again, what Freiburg had before, they would install EAAS on their servers, and anyone who was logged into, their network could access that. But what we've introduced is this concept of if I install EAAS at Yale and publish certain software installation media or publish certain emulation environments, then you at Stanford can fetch and make use of those same resources. And again, just ultimately the goal being there to reduce the redundant work that we're all doing in the field if we all need Adobe Acrobat 9.0. And the focus there, with the copyright concerns, is a really good one, because I should say that the sharing and the distributed access, the copyright concerns that are addressed in the code of best practices for fair use and software preservation is talking about software as a tool for getting to digital collections objects. So we are not assuming that people will be sharing, like the IMF CD-ROM emulated environment that you created. You would not necessarily, you have your copyright concerns that you got into as you described in your presentation. You wouldn't necessarily publish that to another institution like Yale to use, because you have concerns about that being accessed by people beyond the Stanford community. But again, people who might need Windows XP or might need Adobe Acrobat 9 as a tool to get to our own similar collections at our local institutions, that's what we're really trying to enable and help the infrastructure there. Does that, broadly speaking, answer the question?
Yeah, thanks. And like you said, you'll go probably a little bit more into it.
Yes, I'll definitely
second
discuss
part
it.
too.
But it raises a bigger question for me, which is, I understand what you just said, but let's take in the case of my work where Stanford has the emulator running, and they have a piece of copyrighted software that Stanford has a right to show people within the Stanford environment. Is there any reason why somebody at Yale couldn't open up something at Stanford that has not just Windows, 10 running in it, but also has a piece of copyrighted software in it, assuming that's okay with Stanford. It was, if it's
So
okay
yes,
with Stanford, is it okay? Is there any reason why it can't be in the emulator all over the world?
So one thing that we are working on is more sophisticated permissions management for sharing in emulation environments down the line, because absolutely there could be some cases where there are not copyright concerns and someone is perfectly happy with, as you sort of say, someone at Stanford sharing a collection item via emulated environment to someone at another institution. We recognize that that's obviously a use case as well. It's just sort of off the bat for like prototyping V1, we don't want to necessarily be managing everyone's digital collections for them. We're not trying to be a repository system. So our focus is on the sharing of the software and of the emulations, and putting a bit of a divide up between those tools and the collection items themselves. But that's absolutely of further discussion and interest, and sometimes complicated. I mean, the distinction between what is software and what is a collection item, I think, as your pieces will show, Bob, is in itself sometimes a hard one to make. So
okay,
discussion we're looking to have.
So this is Michael. I just want to give, why don't we take maybe I'm showing 10:19 and we're scheduled to be back at 10:25, and Ethan, you need a break.
I could use
yeah, so why don't everybody take 6 minutes? We're going to start promptly again at 10:25. We've got some great stuff. Ethan's going to pick up and talk a little bit about kind of where Easy is going. And then we have 2 more use cases, which are really worth sticking around for: Bob Stein's archive and use case from Stanford University Press. So we'll be back at 10:25. So thanks, everybody.
Thanks, Michael.
Folks, so let's pick up back where we left off. Sorry about the short break. We've got a lot to cover today, but I think it's well worth it. So Ethan, if you could start us off again, that would be great. Thank you.
Yeah, can you all hear me? Yes.
I can hear you.
Thank you. Just getting my notes back in place. So yeah, so in that last section, I hope I addressed kind of broadly why emulation and why now, basically. But for this next shorter, hopefully like 20 minutes and maybe with some more discussion, I'd like to get deeper into the EASY project, what it actually is, and our full program of work. So EASY, if you're not aware, stands for Emulation as a Service Infrastructure. It is a Mellon and Sloan Foundation funded grant project, which started in January 2018 and is hosted at Yale University Library, with the goal being to deploy and scale infrastructure and services for software emulation, including distributed management, sharing, documentation and discovery, and access. So how do we take emulation and emulation as a service, this great platform developed by the team at Freiburg, and how do we make it programmatic? How do we make it automatic? How do we make it applicable to collections that potentially span decades and hundreds or thousands of objects? So our work falls into sort of several buckets here. There's really lots of branching things going on. So kind of our first bucket here is that question of scale and scaling up, which involves a lot of improvements to EAAS itself. So we are working with OpenSLX, which is the sort of commercial wing that it is essentially the same team from the University of Freiburg. They just split off into an entity that could offer commercial support to people trying to use their platform for collections. So we are working with them to streamline EAAS infrastructure and make it easier to deploy, easier to operate, add new features, many of like the things that have already come up in the suggestions and that we've been talking about. There is also a goal of enhancing the usability of it, of the interface, and of sort of the workflows around importing content and creating emulated environments. The team at Freiburg is the first to admit that they are not UX or UI people. And so we have hired a different vendor called Portal Media, who operate out of Wisconsin, who have been hard at work on a new interface to just sort of enhance some of the experience of actually using the EAS platform. And there are also going to be a lot of improvements to performance, to security, and to permissions management to enable that sort of really sophisticated user authentication, management, and sharing features that we were starting to discuss. And that includes basically what you would expect, like integration with single sign-on services at your various academic institutions or OAuth services, etc. Another big bucket is the distributed management aspect. So that is in addition to the improvements to the platform itself, this is where the network comes in, the easy network, sort of capital N there, which is our decentralized network of emulation nodes, and each node being an institution responsible for running and maintaining an instance of the easy platform. That's currently at 7 nodes. So that's Yale, Carnegie Mellon, Notre Dame, University of Virginia, UC San Diego, Georgia Tech, and yourselves at Stanford. So the idea being that like each of those installations, each of those instances is able to share software installation media and emulated environments with each other. They can share and exchange in order to reduce redundant work. Part of the grant goals running through June of this year was also for thousands of pre-configured software environments and software resources to be provided by Yale University Library as kind of a seed collection for the network. And that's been Ewan Cochran, the digital preservation manager at Yale, has been working for years, even before the EASY program started, to sort of build up a collection of legacy software. So that has again served as sort of the starting point for us in creating this system of dependencies that one can use in order to access digital collection objects. There's also our documentation and discovery bucket. We are also working on creating an extended metadata schema or profile for describing software and computer environments, part of that challenge of again, considering software as preservation object in and of itself. Part of the challenge that was discovered is that sort of existing metadata schemas for describing digital objects for preservation did not cover the sorts of things that we're talking about here, like the interrelation between software dependencies, the relation between software applications and operating systems, the relations between software and hardware peripherals, just all a structured way to describe what a computer is and how it works. So we have been working towards an easy metadata model that will there will be comprehensive open machine readable documentation for creating records according to this profile, and obviously everyone who installs the EASY platform, once the model is incorporated into the platform, creating emulation environments and uploading software resources into it will help with the generation of that metadata. And we will also be integrating as much as we can with the Wikidata for Digital Preservation project, which, if you are not familiar with WikiDP, is a really phenomenal project that is looking to use Wikidata as sort of a common across the field, cross discipline linked data repository for all things computing and computing hardware, computing software. The idea being, again, all this metadata that we're generating within the EASY network should be broadly applicable to other people in the digital preservation field, whether they're using EASY or not. We're just trying to, again, sort of broaden the base of people who are performing software preservation in any form across the digital preservation field. and using Wikidata as sort of the shared platform by which to exchange that information. And our final sort of big bucket of work is the access piece, and is the goal of, in addition to sort of the interface that you saw in Michael and Ron's demo, is what we consider sort of like the administrative UI. This is, you know, where digital curators, digital archivists, collection managers, such as everyone on this call, more or less, would be, you know, logging in again to upload software and create emulated environments. But it's not necessarily what a patron, an end user, a scholar, a researcher would see. So there is also this additional piece of developing different services or modules to kind of go on top of the AAS platform that would address these different user communities. And each one of these sort of 4 identified access services is more or less targeting a we've prototyped each of these, but they've developed more and more into developing workflows and targeting specific user communities, as I say. So the emulated CD-ROM environment sharing service, you can more or less think about the IMF CD-ROMs or things that would integrate into a library catalog. These are circulating CD-ROMs, things where, again, like if Yale University could say, hey, we have the same copy, we have the same CD-ROM, the same IMF CD-ROM that you do, rather than we both configure the same environment with that CD-ROM, can we just share those? So that would be a service to support that use case. Virtual reading room service is again, a module that would support much more sophisticated permissions like time and access and location user controls, by which we assume special collections, digital special collections would be more interested in that, in recreating the experience of going to the physical reading room at an archive. The scientific software portal is a bit amorphous, but is intended for the data reproducibility community and relates a lot like to that data export question that we had looking at the IMF CD-ROMs, which is like, okay, maybe someone doesn't actually want to use this data in emulation. How would they actually get it out and use it and reuse it in a contemporary context, cite it, etc. In published studies. And then the final piece being what is called the Universal Virtual Interactor, which would be an API to enable automated interaction with emulation. This being a really general use case here where, again, you just sort of give the UVI any file, any legacy file, and characterization work will be done to identify the format and match it up with an emulated environment within the easy network that would be capable of rendering that file. So a lot of different, you know, that would be a big piece for, again, contributing to sort of the linked data community and building up this base of knowledge about what software and what operating systems could be associated with which file formats and file types. Our team, this is it. This is pretty much everyone. We have Ewan Cochran, who is the digital preservation manager at Yale, is our principal investigator. Seth Anderson, who is on his last week of paternity leave, had a baby in late March, but is our program manager and will be back soon to have this conversation with all of you. Myself, I'm the software preservation analyst for EASY, and so generally documentation, training, and user support for the network is sort of my main focus of work, as well as actually leading a team of student workers at Yale for, again, creating that sort of initial base of environments to share with the network. Klaus and Oleg are the team from OpenSLX, again in Germany, that's Freiburg, who are continuing on what we call the backend technical architecture and development, improving features for EAAS. Casey and Andre are the team out of Wisconsin for Portal Media, working on the front end design, development, improvement of the user experience. Jessica is on the call, Educopia and Spin handling our communications and outreach, and Kat Thornton, independent with Data Current and is our main contact for the Wikidata community, and does a lot of consulting as our semantic architect on the metadata model and how we can contribute our metadata to the broader linked data community. And generally, just to do sort of a summary of what we've been up to since the grant started in 2018 up to now. And starting in January 2018, I mean, was really I mean, all of 2018 was really a year for putting the band together, that is so to say, hiring all the staff that you just saw, defining use cases, identifying stakeholder communities, drafting the initial UI mockups, preparing the project timeline for the next 2 years, starting on the development of features, enabling that network exchange service. So again, the piece of actually saying, okay, I just published an emulated environment from Yale, now you can get it at Stanford. That was the first piece like of technical development that had to be in place before this could really work. And we also started work with institutional partners. So that was when the first members of the EASY network came on board, including you all, including Michael at Stanford as your rep that we've been talking to since 2018. 2019 was a year for testing, basically. That in the first months, I think it was like March or April of 2019, we actually pushed out the what we call the beta release of the EASY platform to all the nodes. So at this point, that was when you all had access to the software and could start testing and creating environments and identifying what it would or could be useful for at your in your collections, and really getting, again, that hands-on feedback that as I've said over and over in these first couple of hours even, you know, is so useful to guiding us for the future. Also allowed me to, you know, start creating training resources for us to really work on the infrastructure for community support, and what it will take for EASY to become a sustainable community in the future. The first few months of early 2020 then really turned to the user experience and the new user interface design, which I hope to show off in a minute. So that's basically our focus has been on actually implementing the UX and UI design that was done over the latter half of 2019 with Portal Media. And right now, where we're at here in May of 2020, is our both dev teams on both the Portal and the OpenSLX side are hard at work on implementing, as I mentioned, that expanded metadata model, the interoperable schema for describing software and computing environments, which is, again, really going to allow for much more thorough documentation and description of software. And again, enable all the sorts of discovery features that are really going to allow our service scale to the level of thousands of resources and integrate in multiple directions, both user-facing into library catalogs and access interfaces, and also to digital repositories and you know, saving software and saving environments as digital objects worthy of preservation in and of themselves. And where are we going? What's the future? Phase 2 of funding from Mellon and Sloan and Yale has been approved, and despite the circumstances, we have been working through all the questions and moving forward with that. So there will be another 2 years at least of the EASY program of work starting in July 2020. So July 2020 through June 2022. And the theme of that will really be towards building a sustainable service. So again, polishing all these various features and functionality that we've shown off here, working through all the sort of nitty-gritty problems that Ron mentioned, so that we can really showcase you know, what this platform can be, as well as scoping and piloting service models, streamlining communications, making it easier for more nodes, more network members to come on board, training more people in the field on emulation, and really working with you all to build a corpus of concrete functional use cases, you know, like the IMF CD-ROMs and like the other examples we're going to see from Bob and from Jasmine this afternoon. Just really build up that collection of use cases that make the quick pitch for emulation across all sectors. So we can push for the more kind of sustainable support that a service like this is going to need into the future, and really just make the argument to anyone we come across of why this is necessary. And so I'm going to wrap up by quickly just showing off a little bit of the new interface running for you all. You can see this is sort of the new dashboard, and I believe even your for Ron and Michael and more experienced members at Stanford, this is going to be a new experience. But you can see you can sort of browse in this bento box style resources. You can bookmark operating systems and software that you use a lot. Run it in an emulator. Again, just have a sort of more user-friendly experience. But I would like to emphasize here that everything you've been seeing that has been created at Stanford already, none of that will be lost. Everything that you all have created, the back end of the EAS platform and the environments you have created, those are all pretty much going to stay the same. The functionality more or less stays the same and is going to migrate really easily into the future, even once we've updated the more sophisticated metadata module. That is really all just going to be about description and discovery and more thorough documentation of the things you've already created. So all of that, again, just generally improving the user experience. You're not going to lose any of the content you've created already, and hopefully things will just get better. So at this point, as this demo just sort of wraps up, I hope maybe we just have a minute or two quickly for burning questions, but otherwise I'll try and answer things in the doc.
We have maybe time for one quick question if somebody has one.
Well, I'm always available over email or Twitter or however you want to ping me if you want to talk more about what you've seen today. But otherwise, I think we should maybe just keep it moving.
No, that sounds great. Thank you so much, Ethan. That was really really helpful and exciting to actually see the new UI examples of it running. That's really super cool. So we have a special treat. We have Bob Stein is up next and is going to talk about what he's been doing in emulation as a service. So Bob, the floor is yours.
Is my screen now being shared?
I see it.
Good.
Looks good.
All right. There we go. So this is going to be a rather different presentation. It's going to be sort of, the context is going to be my archive that I sent to Stanford last October, a couple hundred boxes. And it's sort of a chronological look through this archive, and the issues of emulation are going to come up in order, in effect. I want to, by the way, mention that Colin Holgate and Michael Cohen, who are on this call, were two of my colleagues at Voyager for many years. And when I use the word I in this presentation, it often means many of us, because a lot of this work, all of this work pretty much was collaborative. I grew up in the 60s, and I grew up in the 60s, was born in the 40s, and really got my sort of start in life being politicized at university, where I was a charter member of SDS, the Students for Democratic Society, and several of the boxes that I sent to Stanford have posters and leaflets and newspapers that I collected during my years as a political activist. I had the opportunity to go to China during the, let me see if I can make this smaller. Where's my cursor? Come on, you can do it. Maybe not. Why can't I get my cursor over there? Anyway, I had an opportunity to go to China during the Cultural Revolution. So there are posters, there are books, leaflets from China. And is wrong. Lost the. I understand that we don't need to emulate those things, but what I'm going to try to do with this collection is to create a narrative, and that narrative mixes and matches media types. And so and everything is sort of related. Many of us who started off with new media in the late 70s, early 80s, we were all inspired by a lot of the political struggles that were going on all over the world. And so everything really is related. After I sort of stopped doing political work sort of abruptly in about 1980, and had the good fortune to hang out with Encyclopedia Britannica for a year, and then the research group at Atari. And the thing on the left is a paper I wrote for Britannica, and on the right, memos between me and Alan Kay when he was at Atari. And this is from a series of drawings that I've given to Stanford, showing that we did these in 1981, showing how we thought the Encyclopedia of the Future would be used. That's an architect in Japan studying Japanese architecture, while a teacher in Tokyo is teaching her class about Western architecture. Shortly thereafter, I started something called the Criterion Collection, and this is an interesting emulation problem. One of the things we did with Criterion was we started doing commentary tracks on films, so that with a Laserdisc, you could play the film track but then you could switch to a commentary track.
And eat bananas all day and belch, so it didn't work. So what he did was he went down to the San Diego Zoo and he recorded the lion cage at feeding time. He reversed it, dropped it an octave, and that became Kong's roar.
So we're going to need to find a way to emulate a Laserdisc, because we do want people to have that opportunity to access the commentary tracks in the context of a film. And there are a lot of Laserdiscs, not just feature films, that involve needing to switch between tracks. So small emulation, but it's going to be important. After the Criterion Collection, this is a screenshot from what became sort of the world's first viable commercial CD-ROM. It was everything you wanted to know about Beethoven's Ninth Symphony. I can't show it in the emulator today because these CD-ROMs had dual sessions. They had a audio component, basically a CD, and a data component. And we've yet to figure out how to upload both into the emulator at the same time and to run the CD. In 1991, Apple gave us a prototype of the first Mac PowerBook. A friend of mine who was visiting from the National Library of Austria grabbed it out of my hands, put the first 10 pages of Paul Bowles' Sheltering Sky into a HyperCard stack. We looked at it together and went, oh, we could actually do electronic books now. So a couple of months later, at the beginning of 1992, this is something Colin worked on extensively. We released the first expanded books from Voyager. And so this is 1992. This is 15 years before the Kindle. Again, we can't show you this in the emulator yet because we have not been able to get our hands on a floppy disk that we could upload during the stay-at-home period. But this was pretty advanced in 1992. You could write notes in the margin. You could click on words and get a list of all the occurrences of that word in context with words on either side. You could dog-ear pages. You could put paper clips on pages. You could mark passages with a black line in the margin. They were pretty fabulous in lots of ways, except, of course, it was way too early for anything like this. So we went on from there when in December of 1901, Apple released the first version of QuickTime, and we had the rights to A Hard Day's Night, and so we decided to publish that, and it was the very first feature film released on a CD-ROM using QuickTime. Let me see if I can get this actually running in the emulator. Let's see. I'm sorry, the emulator is somewhat wonky sometimes with video. We could change the size. Oh, this is painful. I'm gonna switch to a. You could access the film in lots of different ways. For example, you could go scene by scene. Here's looking for Paul's grandfather. I realize what's wrong here is that I think it's the sharing of the screen is slowing down the video terribly. And you could also search by, you know what? This is silly. Let me do it differently. No, none of this is going to work. Hold on. Share screen. Apple released QuickTime in December of 1991. And shortly in the new year of 1992, we published A Hard Day's Night, the first feature film published on ROM. The whole film is here. And you can watch it in the QuickTime postage stamp size, or you could double it. You could look at this film by scene. For example, we can go to looking for Paul's grandfather.
He's been gone a long time. Who? Paul's grandfather.
But we could also look for it with the script. Let's go looking for Paul's grandfather, and it'll continue from where we were.
Oh, just where'd he go? Down the, we'll give him a couple of minutes then.
And the page will turn with the movie. And you could actually search for songs, for cast, for scenes. Any way you want to sort of move around the film, you can do that. There's also a supplementary section with things like this early film by the director, Richard Lester.
Remember me? Yeah. Let's try the next floor down.
And at the end, there was a photo gallery. You could page through these. So this was the way we presented a film circa, on a CD-ROM anyway, digitally, in 1991. And I'm not even going to try to do it in the emulator for this next one. In 1993, we decided we wanted to try to do more with the electronic book concept. And we had this idea that with really difficult books, if we could have the author inside the book explaining her ideas, that it would really help people understand them. And a perfect example is what we did with Marvin Minsky's Society of Mind. Marvin was one of the founders of artificial intelligence, and he wrote in a Society of Mind as an attempt to present his ideas in a popular mode. Realistically, the book was still quite difficult, so we thought we'd present the book with Marvin trying to explain some of the concepts directly. So the entire book is here. And what we did was, that was really different and had never been done before, was we shot Marvin on a green screen so that he could actually appear not in a window in the book, but actually literally on the page.
They'll say, well, I'm me. What's that? Well, if they've studied a philosophy course, maybe they'll say, well, I have a body and a mind. And I say, well, we know all about bodies, and the human body isn't very different from a guinea pig body anyway, so nothing so great about that.
So my favorite example of this, though, occurs in a different chapter, the chapter on reasoning, the section on mathematics made hard, and here, Marvin talks about the problem of math
the problem
vocabulary.
with children learning mathematics in this culture is that we have a very strange attitude toward it. We don't have any mathematical words. If you look at any other subject in school, maybe the child learns a dozen words every day in history or language or social studies or whatever, geography, you know. By the time the child is through 12 years of school, they probably know a couple of thousand words in each subject, all the people involved in it and all the objects and so forth. In mathematics, the children don't even know the adjective for which situation you use addition. They learn addition, subtraction, and junk like that.
Interestingly, when we did this in 1993, we assumed that in the future, this would be common, that all books would have the author, when it was appropriate at least, on the page talking directly to the reader. It's an interesting question about how come it hasn't happened. So let me just really quickly, a couple more things. So one of the things, when this sort of stuff got out from Voyager, people all over the world started sending us things, particularly artists. So that this archive that Stanford now has literally hundreds and hundreds of original work by artists that really will never be seen unless we sort of get it up in an emulator. And I know from having lived with this stuff over the years, there's a remarkable repository of interesting work here. To finish, I just want to show you two things that came later. What you're going to see here is, what's interesting about what I'm going to show you is not the thing itself, but how it was made. This was made in a tool that we made in late 1999 called TK3, and it's an electronic book that I put together in just a couple of hours. And it's I always started with "as we may think" whenever we got a new tool, and it mentions in the preface to the article in Scientific American the Emerson's American Scholars Speech. So I included the entire American Scholars Speech. You can click on Babbage to go to his Wikipedia article. One of my favorite things in here, though, was the voter gets, we've all heard about the voter. So I found a schematic diagram of it and included it. And also,
Will you please make the voter safe for our Eastern listeners? Good evening, radio audience.
That's not a simulation of the voter from 1939. That is the voter in 1939. And then lastly, I want to show something else. The Beethoven that I showed earlier, the Beethoven took a really fantastic programmer almost a year to program in HyperCard. It was a very complicated piece of work back then. This was a Mellon-funded project also called Sophie, where we tried to develop a authoring environment so that people who were sort of subject experts but not programmers could assemble something. So this program on Mozart is something that, again, I put it together, and I pretty much failed Physics for Poets, but I put this together in an afternoon. And I'll just show you the parts of it very quickly. That's not good. Oh, what a shame. Let me cancel this. Give me one more minute, Michael. See if I can make this work.
No problem. Why Bob is working on that. We've actually given, as you can see, Bob access to our instance, our Stanford node here. And it's really been critical, as you can see, because there's lots of things that work great and things that don't. But more importantly, just the level of knowledge of some of these space environments has been really critical to helping us to get it to run. So thanks, Bob, for being patient with us and playing with our imperfect car that's being built.
Okay. Thank you for being, let me see, desktop. Let's see, where's the desktop? Mozart. Second, is it going to open or not? It may not. What a shame. Because what's amazing here, and I wish that I was able to show it to you, is that what we were working towards was really sort of the original promise of HyperCard, which would let anybody start to assemble sophisticated interactive media documents. Oh well. I think I'm going to turn it back to you, Michael. I should have made a video version of this one too.
Oh, no worries, Bob. There's a lot to chew on here. So does anybody, we've got a few minutes for questions. Does anybody have any questions about what Bob has been showing us?
Hi. Yeah. Maybe it's not a question about what Bob has showed us, but it reminded me of, you know, when you were showing the laser disc, and also, this is Hanson, by the way, and also the Beethoven, the CD-ROM with the audio track, reminded me that, you know, at Computer History Museum, we have some Laserdisc titles that are paired with HyperCard stacks on the Mac. And we had a researcher who wanted to access these. And we actually had to set up an old Mac and a physical Laserdisc player to connect it to. And I was wondering if you know, if it doesn't look like there's any way in the system to emulate that kind of interaction between two completely different pieces of hardware.
Yeah, I mean, I think there isn't now. I mean, that's one of the reasons why I showed this, was because I think that I mean, although I gave 3 Laserdisc players to Stanford, that's just a hardware combination that just doesn't exist anymore. So we're going to have to simulate these, I think, by digitizing the Laserdiscs and doing some, you know, behind the scenes programming to emulate.
Yeah. Actually, you know, at the time I was working with Andrew, who was with us, and you know, he mentioned that these laserdiscs are actually analog. So how do you digitize a laserdisc was actually a pretty open question. We were wondering.
Shall I say something, Bob, about that?
Of course, Colin.
That'd be
All
great.
right, so just exactly on that question, A Hard Day's Night, the one you saw a little while ago, we actually did digitize from a Laserdisc. We did it a frame grab at a time, and the big problem you got hardware-wise is they use serial ports that don't exist anymore. On the audio CDs like Beethoven's, one of the ideas to work around that is to digitize the audio and change all of the CD audio controlling software to access a WAV file, let's say. We've done that in other products. Same thing would apply with the Laserdisc. We would digitize the video into a MP4 and then change the software to address it as an MP4 instead of being a serial device.
Okay. Can you get the same kind of, you know, like with a Laserdisc, you could freeze on a single frame. And I thought that MP4 files, you know, because of the compression, you can't necessarily freeze on any individual frame with the same kind of resolution that you could with the original Laserdisc. Is that correct?
Some of that's true. It may depend on whether you're talking about playing it with QuickTime or playing it with some other generic MP4 player. A lot of video players in general might only be able to go to the nearest keyframe. Something like QuickTime is a good enough technology that it could take you to any frame, and we were using QuickTime. So with A Hard Day's Night, we could stop or start at any point.
Cool, thank you.
We have time for another question if somebody has something they want to talk about what we've seen.
I think I've got it working, Michael. I'm going to share my screen again, if that's okay.
Shoot, Bob. Go for
it. Share screen. Share screen. Share. Okay, there we go. So
I'm Robert Winter, and it's my pleasure to invite you to join me in a listening experience that the late 18th century regarded as one of its most...
So one of the really cool things we did here was we chapterized this Mozart quartet. There was a whole section which sort of contextualizes the music with glossary sections and audio sections. But the real heart of these companions or music companions were this. Where the music starts to play, and you can get a running commentary. And then Robert Winter would pop up.
Would have been more accurate is in calling this the chromatic quartet, because in fact, it's enormously chromatic. In fact, this first page, this slow introduction, and of course, if we think about what I think the 19th century would have been more accurate is in calling it.
So what's important to understand here is that this is something that I really did put it together in an afternoon, and it's going to be very exciting to make these tools available inside of the emulator. The amount of, I have so much fantastic work that students and teachers did in these tools that will be fantastic to show off. And also to make, what I mostly want to do is inspire people who are working now to start to build tools that empower creative people in ways that really we haven't sort of gotten to yet, but really need to. Anyway, thanks for the opportunity. And I just want to say what a huge pleasure and excitement it is to be working with the team of people at Stanford in this emulation mode. And Colin, thank you so much for all of your help. I mean, we're really making fantastic progress, and it is very, very exciting. Thank you.
Well, thank you, Bob, and thanks everyone. And we're going to now transition to our last use case, which is Jasmine Mulligan from the Stanford University Press.
Hello, I'm Jasmine from Stanford University Press, and I want to show a use case that we've been working on. Let me share my screen here. Oops. Present. Okay, just want to confirm that everyone can see what's on the screen.
Looks good.
All right, great. And while that's working, let me move my notes. Okay. So Stanford University Press is working right now on a Mellon-funded initiative, which has been going on since 2016 and is set to continue progressing until 2022. It's a program for the University Press to publish open access, web-based interactive publications. And these publications, the closest analog, I guess you could say, is just a website. They exist online. Anyone with the URL can navigate to those publications, and then they can interact with them. There's no print corollary, basically. They use all of the affordances of the web to present something that couldn't actually be formatted in a traditional print book. So they rely on those interactions to help make the scholarly arguments that they make. These publications are platform agnostic, so we don't require authors who are writing these digital monographs to use a specific platform. So there are some other presses who are embarking on similar programs, and they are creating, for instance, if you've heard of the Fulcrum platform or Manifold from University of Minnesota, University of Michigan presses, they're both working on similar initiatives, also funded by Mellon, but they're doing so with a kind of a dictated platform that they are helping to build. So these publications are using like static HTML, CSS, JavaScript, any custom built applications that the authors and their developers have deemed useful for the presentation of the arguments that they're making. We have so far 6 open access publications to date. They range from custom built platforms to actually 3 of them are using the Scalar platform, which was developed by University of Southern California's ANVC program. So a lot of digital scholars are working in that platform right now. It's also open source. And the fact that three of our publications actually share that platform helps somewhat with the preservation of the work that we're publishing, in that if something scales, if we can do something in that platform, then we can, if we can preserve one publication on that platform, then we can possibly apply those practices to preserving the other publications on that platform. So the preservation pathways that we've had to start looking at for these types of publications include simply depositing all of the components that live on the server into the Stanford Digital Repository so that we have copies of them, and they are preserved. The bits are essentially preserved. The issue with that is that that content is kind of taken out of its context. And so while researchers can access, like, say, a specific HTML file or a specific image, they can't see all of those parts playing in the context together in which they were published. So we're also exploring another preservation pathway, which is web archiving. And we're working with Ilya Kramer on some custom web archiving work. And I'm hoping I can turn this presentation over to him at the very end to talk a little bit about what he's doing. And then the other pathway we're exploring, of course, is emulation. So I want to go into a little bit what this one publication looks like that we're focusing on. These are the 6 publications I mentioned before. So we're going to focus on filming revolution. So this is the first publication that I have plugged into Easy to start playing with. It wasn't the first publication that we released from the press, but it is one that is very visually interesting and dynamic, and one that I felt like, because it was custom built, could benefit from testing in this environment. So we chose Filming Revolution for this project, and this is essentially the home page, or what we call the cover page. And we have one of these cover pages for each of the publications. They live separately from the full publication itself, in a separate location on the server, just so that the cover page is isolated from any decay that might happen in the publication itself. It's a static HTML, CSS, so it's easily updatable. Its primary update would probably be the redirection of that enter button, so that preserved versions could replace essentially the live web version as the project starts to decay. So what is this publication? Well, this is, hopefully this begins playing, yes. So this is a 2018 publication, and the key there with the idea that it's a publication is that its state is fixed. So there are no updates to the project once it is published. So after 2018, there was no update to the backend code. There's no update to any of the content. It exists as it was released the day it was published. This project is a pivotal contribution to scholarly communication surrounding the 2011 Egyptian revolution and its aftermath. It's essentially a project that where the author has interviewed several filmmakers in Egypt and asked them kind of what they, how they saw film impacting or responding to the events in Egypt. It is unique in its format in that it actually uses video to make an argument about video. And it can use visual pathways to show the multilinear network of agents involved in those films. So it's able to capture the multilinearity of complex historical events and a culture's reaction to them. Let's see. So the operating system requirements for this project would essentially be a server stack. And hopefully that would be applicable to all of the publications that are also hosted on that same server. So why, oops, I should also mention that it's important to preserve this type of content because obviously the content itself, future scholarly publications will need to be able to cite this project, and archival footage of the filmmakers who experienced the revolution. These videos that populate the site, there are over 400 videos in the site, should also be preserved for the scholarly record. And then in terms of the context, this is essentially an example of a 2018 scholarly digital publication. So it's valuable to both the field of study, but also to digital humanities scholarship. There's the aspect of bibliographic and textual studies where it's important to understand like what operating systems, what tools, what technologies scholars were using to make their scholarly arguments during this period. And also, as I mentioned, there are other presses generating and publishing this type of content now. And even though while it's still pretty innovative and not widely adopted format by a lot of publishers, it's something that since Mellon is funding it, it's something that hopefully will be increasing like in the next decade or so. So all of this is hard, of course, because it's difficult to preserve web content. So in general, we are trying to balance with these publications, balance innovation with sustainability and preservability. So we're trying to mitigate as much as possible upstream while these projects are being developed by the authors, to try and get them to think about what they're producing in terms of its future accessibility. So while we can make certain guidelines and recommendations and requirements, which we do, we also want to leave the door open for innovation and use of technology that's new and exciting. So to that end, we end up having to preserve, use the tools that we have now to preserve what exists. So we want to preserve the interactive experience as part of the argument. So we're exploring further into like web archiving and emulation, even while we're also just preserving the bits in a digital repository. We also want, though, to preserve the underlying code for future researchers who specifically value that as part of the materiality of the research that's being presented. So that's where emulation in some ways offers some advantages over web archiving, in the sense that we can capture all of those moving parts and all of the dependencies while we're also presenting the content in a high fidelity representation. So that's kind of what we're trying to preserve, what we're trying to do. And the easy environment is providing one possible solution. So we've been testing it in hopes that we can preserve that underlying code, but also provide researchers access to the interactive publication itself. So there are different ways to approach like importing an environment or creating an environment in the easy interface. And what we've seen so far is a little bit different from the approach that I took on this. So I should say that our testing at the press with easy is very much a work in progress. So what I'll be showing here now is just a walkthrough of what we've done so far. And there are a lot of other ways to do this, even in easy. So I first, for this project, created the environment in VirtualBox. And so there were a few reasons for that. Really, I created this environment before I even started thinking about emulation. So I had done this as an exercise for something completely different. But once I saw that you could actually import a VDI, a virtual disk image, into easy, I figured I have this, so why not try it this way? It also, though, seems like as I went through that process, I could identify some reasons why maybe this would be a good approach for this type of content as well. And that's because there are a lot of components in the stack. There's, I mean, in a LAMP setting, I mean, you have to have all of these different configurations as well. So I wanted to load up software and systems that were not necessarily older systems, but newer systems, newer open source, like Linux distributions or things like that. So building that environment, configuring it with all of the security settings and everything like that was a process in itself that just seems to go more quickly, building it in VirtualBox and then later just importing that whole thing over to Easy. Let's see. I mean, I'll just go ahead and like let this run. It probably won't finish, but this is the VirtualBox, just a screencast from what the publication looks like in VirtualBox. So if you compare this to what you saw just a few minutes ago with the live web version, it looks pretty similar. There are some glitches you can see, like at the bottom, the bottom menu where it says tutorial. There should be other options there, but it is showing that JavaScript tutorial at the kind of overlay at the beginning. And then as it goes through, you'll see that it has a lot of the same features that the original version had. And I wonder if I can speed it along. There you go. So you can kind of see the visual complexity with how the content is organized. The key here, though, I should mention, it's very important, is that the videos themselves live in Vimeo. So they are external web content. So on the live web, of course, that API brings those videos in seamlessly. A reader doesn't even necessarily know they're coming from somewhere else. But once we import it into a self-contained environment that no longer has access to the Vimeo material, then obviously that very important resource and very important part of the publication is no longer part of the publication. So there are some possible workarounds for this. We have the video content available just as their raw files, and those are things that as a package we could load into the virtualized environment, but that would still be removing that content from the context. So as someone was browsing the publication, they may then still have to use cues from the URL perhaps to locate that video in a separate folder that's installed on the hard drive. All right. So once this was created, though, in the VirtualBox environment, then I could import it into Easy. And so this is just a screencast of me doing that. And there are some configuration settings to kind of tweak. A long wait, that's sped up times 20, actually, in the screencast. So it takes a while to load, of course. But once it is loaded, then it looks much like the use cases that we've seen, where the operating system starts up, it runs its tasks, and you can see all of that happening. I think I sped all of this up. I should have anyway. You can see that it's running, but it's running pretty slowly. The content files, as I mentioned, would also need to be loaded, which is possible to do to edit an environment once it's imported. But it is then difficult to further refine this environment within the emulator, just because it is such a complex stack to go in and kind of change settings. Like for instance, I wanted to be able to change like the startup applications so that a browser would actually come up as soon as the system booted up, and then the home page was set to the home page that I wanted to display, the landing page essentially. And just that type of thing is just much harder to do once you're actually doing it inside the emulator versus in VirtualBox. Okay, so I'll just skip that. So this is the point that I could get to so far with this test run. So importing the environment works, launching the environment, running the environment works. Getting the site to load, I've had kind of inconsistent results. So this is as far as I've gotten. It says it's loading. Other times before I tried to capture this screencast, I have at least seen the visual network display, and I can navigate the essays. The essays do look a little bit different. They don't have those connecting lines between the linked resources. So I'm still unsure why exactly there are those inconsistencies in this environment versus in VirtualBox versus the live web environment. And these are all things that I need to be able to just nail down to improve the functionality of this. So the challenges, of course, with this particular type of content is that any external web content can't be seamlessly viewed in its original context. It needs to be ported in separately. LAMP is a complex environment to set up and configure. It's worth asking whether it's maybe just not suitable to this type of, to this tool. So there are other, solutions that are more, that are designed more specifically for web content. What else? So the versions can be an issue too. Like this site runs on an older version of PHP that's no longer supported. So if we were to try to bring in other publications to the same environment, then we would have to configure multiple PHP versions and maybe different browsers could use different ones, just a lot of different configuration situations. So the next steps then for continued testing with Easy at least is to maybe clean up the Linux default program stack. So there's a lot of stuff running in this emulation that doesn't necessarily need to be running. So we don't need a calculator. We don't need the random programs that are just installed in the version of Debian that I had loaded. We don't need like the Minesweeper or whatever. I also want to configure auto browser launch on startup. We need to just try importing maybe multiple publications into one emulation. And then more generally though, I think that we want to continue exploring alternative archiving options. So, and maybe there's some overlap too between the affordances of emulation and the potentials with like web archiving and just other solutions that we've been exploring. So I want to, while we still have a little bit of time, hand this off to Ilya. I think he has some things to add here about the work that he's doing with us for web archiving. So let me unshare.
Hi, thanks, Jasmine. Yes, so I wanted to kind of pick that up and kind of talk a little bit about the work that I'm doing, and I'll share my screen as well. And so what I'm actually working on is kind of an environment system, or essentially a web-first emulation system that specifically targets websites and combines web archives and server preservation with that. And so here's just a quick demo of Filming Revolution running in this system in one of the many modes that it has. So it's using Chrome 76, and we start directly with the browser. You could also, so you could browse in this remote browser that I have. And of course, the key of this is that all of the video content is part of the system, which is necessary to interact with it. And so right now it's running in another browser inside of my browser, and so there might be a little bit of lag in loading it. It's also available in my native browser as well in this mode, so that this should actually load a little bit faster. And again, all of the animations are here, and kind of talk about a little bit why I'm taking this approach and what I'm doing. Put together like a few quick notes here. So I think a key question is sort of what is at risk exactly, and when it comes to a website, there's a server component, and then there's the actual interaction that happens in the web browser. And so in the case of the server, it's using a standard LAMP stack, as Jasmine mentioned. But actually, the LAMP stack is, although it took some time to set it up in Easy, it's actually a very, very common, very standard piece of software. I mean, it's easily deployed in cloud services. It's easily containerized. It's not legacy like some of the other software that we've seen. It's not some software from the 90s. It's actually something that's currently available with today's technology. And so the server component, which is what Jasmine was able to put into Easy, is the total of that is about 40 megabytes. The web archive component, also all of the videos, all of the interviews in this piece, there's about 450 videos. They're all loaded from Vimeo. So the size of those is about 15, 16 gigabytes. There may be some duplicates included. And Vimeo sometimes serves them in different formats. The videos can be deleted from Vimeo at any time. And yeah, so essentially, I would even say that preserving the server component here is the easy part. The hard part of the site and sort of what makes it valuable is what the user actually sees in the browser, which unfortunately can only be captured with the web archive because we don't have access to Vimeo servers. We can't get that data from Vimeo. So it's possible to overlay the 15, 16 gigabyte web archive with the kind of preserved server component. And just kind of a little bit of what I'm working on. The first part of it is the automatic containerization preservation of the LAMP stack. Sort of the hard part that Jasmine was working on. I actually see that as sort of the easier part in some ways because the LAMP stack is a standardized. Obviously there are variations, but it's something that's definitely doable because it's widespread software that's in today's in use today, and so we could automatically have a workflow that takes the LAMP stack, puts it into, say, a Docker container, or deploy and makes it easily deployable in the cloud or in another system. The hard part, though, is actually then determining what needs to be crawled. So in the case of this site, there's about 450, 460 Vimeo videos that I had to extract from a database. Doing that automatically is sort of the tricky part. And then also, of course, scaling crawling infrastructure to be able to crawl all those videos in a particular format. And then finally is just having a system that launches, essentially launches the web archive overlaid with the server. And so that's kind of what I've demoed here is basically this system is we'll go to this, so it's actually a web archive. So the bulk of the 15 gigabytes of data is coming from the web archive. Only a small percentage is coming from that preserved server. Yeah, I'm the only person working on this right now is me. So it's moving along. Some other considerations, and we probably don't have much time, is it's also preserving a browser, in this case Chrome 76, and there are some trade-offs there. If using the preserved browser, you have access to something like Flash. However, for a video and animation heavy site like Filming Revolution, just using the user's native browser whenever possible makes the most sense to have the best experience. And this is also kind of where this differs from Easy a little bit, because Easy brings emulation to the web, but when it comes to websites and web servers, they're all, by definition, are already on the web. So we don't necessarily need to emulate that unless there's a specific technology like Flash. And again, all of this is dependent. And I can share this later, but yeah, this is really dependent on websites, how much of a website is coming from external sources, what are the technology dependencies, is all of it hosted on your own site or on Vimeo, for example. So it really depends on the exact infrastructure of the site, and we really could use more methodology on how to even determine that. So, for example, a site with primarily video-based content, a web archive is really the only way to go. But if it's a custom web server that doesn't use Vimeo, then maybe a simple server preservation may be sufficient. Although most sites will probably require a combination of both to have the full preservation and complete user experience as intended. Yeah, that's it for me. I'll turn it over back to Jasmine.
Yeah, thank you, Ilya. So we're working with Ilya through the rest of this year as part of our grant at the press to really focus on how we're going to extend the life of these web publications and extend the just the availability of them as part of the scholarly record. So thank you for helping us out there. And now I will give it back to Michael.
Thanks, Jasmine. Thanks, Ilya. This was really interesting set of use cases, and I hope folks have really figured out that we asked people to try very different things with our emulation as a service. Very specific. There was a method to the madness of having some very different use cases actually thrown up against this type of technology. And as you can see, there's plenty of things that work really well. There's some things that don't. But really getting a sense of what types of content would work has been one of the main focuses for some of the pilots that we've been running. We've got maybe time for one quick question for Jasmine or Ilya, and then we're going to move quickly to sort of a wrap up. Does anybody have a question for Jasmine or Ilya? Well, there was a lot to think about there, so I think we're all a little bit. It's been a long morning, but anyways, I wanted to transition this. We've seen some examples of how Stanford is really testing the emulation as a service. We've got these 3 examples: the IMF. We've got the work that Bob and his colleagues have been doing with his archive. And we've definitely seen the press throwing some materials in there. And I just want to call out, Jasmine, you probably had the toughest job, just because like being able to work over the network, since we're all working from home now and trying to load 5 GB files. Thank you. I know it hasn't been easy, but there's been a lot of really great work behind this. We've definitely seen kind of the heterogeneous nature of these types of objects. I know one of the things that the Stanford team is really hoping to do is to sort of get the new version installed of the software that has some more capabilities for actually being able to work a little bit better in the environment, and then actually documenting our use cases and how they've gone through. But I want to really open up the floor for an open-ended discussion for the time we have remaining of kind of next steps, things that strike some of the participants as particularly challenging or interesting. The floor is ours to use for this 15 minutes. And just to prompt people, I mean, we could you know, one of the things could be what somebody sees as next steps for the work that we're actually seeing here. That's one potential thing we could talk about.
I actually have a question for some of the metadata specialists who are at the symposium here. If anyone wants to speak up about it, like what were some of your thoughts, like that you were thinking about during, say, Bob's use case, for example? What were some of the metadata questions that were like floating to mind for you? As anyone who wants to respond.
metadata about particular elements, particular configurations? I mean,
yeah, I mean, like, and getting the, like, if you're using multiple, yeah, the elements, getting the elements to talk to each other again. I think that was something that kind of resonated across each of the talks a little bit for me. It was, what were some of the things that you might think about or questions you might have for the easy folks?
as one of the producers of several of the things that Bob demoed, I know that the assets that we delivered as products, like Hard Day's Night or the Macbeth CD I did and others, are not just text, are not just graphics, are not just embedded media, but individual media assets as well that are stored in a variety of ways. And how deep does the metadata go in terms of describing what's on those emulated assets? Because I know that, you know, in Macbeth we had hundreds upon hundreds of picture files stored that were brought into HyperCard to be shown at particular times. And how does that all get cataloged?
Yeah, I mean, I think ultimately that seems like a really important piece in order to for making the environment operate in the way that it was like the disk or something was originally intended. All right, and so maybe that's like some of the missing pieces happen because there's some of the metadata gets lost, or the crosswalks between either, like in some cases, like with the Laserdisc question, almost as if they need to be created.
Regina, another thing is that we don't have a registry for the software itself. I mean, just at the very, very most elementary level of discoverability, there isn't a listing, say, for the Cabernetti collection that would tie in to SearchWorks easily right now. I mean, we go through the finding aid for that. And then if we're talking about across institutions, which seems like easy is a great solution for, we don't have a tool that would enable us to search across institutions for the software that's available. I mean, even before we get to the level of description and detail, there's just the basic information about what the collection is that still needs to be put together.
Mm-hmm. I mean, and I thought it was interesting in Ron's presentation too about, he knew so much about the IMF data, and some of that would a future user understand what to click on, where to decide how to get to the data that they might be, or they just have to play with it until they find what they're looking for.
I think in some cases, Regina, with the CD-ROM, there are guides. I mean, I know with the IMF, they would embed basic how-tos, so with that respect, that's why making sure that all of that supplementary material that was on the CD that required the appropriate Adobe viewer version, that was important. So in that respect, for that information, I think that's the best way to communicate that to the user.
So when you were working with the IMF CD-ROM, so it does show up in the emulator, some of those guides?
Yes, so that Ron had showed that kind of initially, which is when he was doing the demo, those guides are there. But that was also some of the other contextual information that we were talking about providing as well for the users in the emulated environment. So if there was a way to give like a visual how-to for some of this, if that was necessary. So like, I mean, again, to I guess how Michael framed it was like, well, what metadata, what kind of metadata are we talking about? The technical metadata that describes the software and the versions, the descriptive metadata, And I think for each of these different types of objects or materials that we're putting in, that will require kind of an assessment of what is going to be necessary. I think for me, the question is, what information is required for somebody to be able to do what they wanted to do in this environment? So what is necessary for the IMF environment for someone to get the data out, to query the data and get the data out of the system, so that way they can take it and use it in the way that they need.
Regina, maybe it might be helpful. Oh, I'm sorry, Michael, go ahead.
No, go ahead. Go ahead, Jessica.
Well, I'll try to make this quick, Michael. So just as a follow-on to Kris's response, Regina, a few things. One is that there's been a lot of discussion about the contextual manuals and technical documentation, especially for interfaces, whether it's specific commands for a command line interface or effectively how to navigate using your arrow keys in an older version of AutoCAD. This has come up again and again with all of the cohort members, so both the cohort members, the other Easy Nodes and the Easy Network, as well as the group of institutions that has been participating in the Fostering Communities of Practice grant cohort, which is the sister cohort to the founding Easy Nodes, and they've all had an Easy Sandbox that they've been using for the last couple of years. So one of the results of that project, which those deliverables will come out in mid-June, which includes some additional institutional documentation around software curation, emulation workflows, and some additional use cases that folks can ponder over. But one of the other results is that there really needs to be an exploratory grant project. And this is something that we've been talking about inside Easy for a while too, so I think a subject of continued discussion, but we effectively are going to need to do some kind of exploratory study that looks at the manuals that have already been digitized by the Internet Archive and are available right now, compared with some of the other technical documentation or user documentation that's important for making meaning out of these emulation experiences, effectively do a landscape scan of who has some of this additional documentation, where it's located, what subset is digitized, what subset is not, and maybe use as a sort of a starting point what is already in the Easy Network or in each of the node instances, and comparing that against those broader corpora. And then figuring out where we go from there. If ultimately what we want to do is create some kind of federated search across that documentation that could be done within the Easy interface. Yeah, in order for users to be able to have some guidance or to see what documentation is currently available. So just as an idea about how we solve this problem collectively, since it's a big challenge that we're all facing, that's an ongoing conversation, so we could follow up more about that. And then another thing worth mentioning that's in the FCOP documentation is this notion of tiers of curation. So I think this has come up, maybe not as explicitly, but it's come up, I think, several times today, which is this general question of how do you know when to use emulation? How do you know like what the end user, or like what's your criteria for determining which of these tools to use, like migrating the data out, using emulation to migrate data versus using emulation to provide an experience to a user of the UI. And so I think that's another kind of collective documentation and set, or conversation and set of documentation coming out, which is how some of your sister institutions are thinking about ways of making those decisions. And then to Kris's point, how the decisions about your tier of curation, or rather really your tier of access, is going to inform which metadata is really critical for those specific collection items. So just know that y'all are, yeah, all these big questions, you know, you're not alone. You have partners that are facing this with you. So yeah, and I apologize, Michael, for interrupting you.
I had an idea, in part to answer to Michael's point. Maybe we as uploaders of content should have a section where we transpose all of the credits from all of the credit pages of the title we're uploading that would cover the, well, where did that photograph come from side of things.
Yeah, I was going to respond. Regina, I think you raised a really important question, but I feel like at this stage, we're kind of like in the pre-Henry Ford standardization and, you know, sort of automation or whatever of building a car. We're all kind of building our own car, trying to figure it out. But I feel like there needs to be some, you know, continued effort to try to more collectivize the metadata more from the creation side of these environments. So like, for example, some way to quickly identify certain kinds of specifications for some software you're going to try to do, or, you know, whatever. And then you can easily put that criteria in and get something off the shelf that's been created as that collection, you know, of stuff continues to build, rather than having to kind of, you know, view a whole big list and try to guess that this is going to work, and then find out, oh, I need this. And then you have to keep kind of piecemeal adding different components to your environment as you're trying to make it so that whatever application, like the IMF thing, actually functions. So I think from the creation side, I think that's going to be important at some point, but I feel like we're, you know, that's something that's going to have to happen when it's ready to more happen, and we can focus more attention on that. The other side of it is from the user standpoint. How can users easily identify what they want and stuff? And I think that's the other level of figuring out how to best expose the metadata for better searchability and finding things. And then the third point actually is something that I don't think we usually do. I mean, in SSDS, we don't necessarily always are able to write self-service sort of instructions on how to use every single application or website that has data. So that's the role of a data librarian, or someone who kind of can sit there with someone and consult with them and see where are they stumbling and where are they on, versus trying to write together some sort of comprehensive guide that can, you know, that people can figure it out on their own. So that to me is going to be a harder nut, because it's almost every user comes to an application uniquely with their own, you know, sort of expertise or experience. And so how to capture that level of metadata and make it available to me is more of a challenge.
I also
see Michael has his hand up.
There's just one basic question I have that's been in the back of my mind since this whole symposium started, and that is the fundamental question I learned to ask in user interface school: who's the user? I mean, literally, I know in one sense it's, you know, anybody, but is this, you know, aimed primarily at academics? Is it aimed at a general audience? Is it aimed at students? There are a whole number of questions as to how you design the interface for this based upon who your user communities are.
Yeah, I want to second that, because to me, I have a pretty broad view of what metadata is, and for projects like ours, as opposed to the IMF, where you're not trying to manipulate or get data out, the question of contextualizing the project, to me, is a metadata question. And as Michael says, who are you contextualizing it for? You know, people who are old, who did it a long time ago, young people now who are studying, or a generation or two or three or four from now. And the question of metadata becomes more and more complex the broader your sense is of who might be looking at this and why.
Yeah, I mean, especially if we compare the different use cases across, you know, that we saw today, they're all different types of use case, you know, users that you could define. But I think that's a good point about contextualizing, trying to understand why you're accessing the software to begin with, or the content to begin with. So,
there's always one more question.
Yeah.
So this is Michael. We're at our allotted time, so I don't want us to overextend too much more than we've already committed to. I do want to follow up with just a couple things. There is going to be a survey that'll go out probably tomorrow that's going to have some questions about how this went, things that you want to learn more going forward, next steps, that sort of thing. So please do take the time to fill it out if you can, even if you're not a Stanford person. We're interested in your perspective and your feedback. We're kind of making this up as we go along with our new current work from home environment. So I know one of the things that we were, as a team, the Stanford team that was putting this together was thinking about was how do we incorporate hands-on activities? And we didn't really get a chance to solve that. But now that we're all working from home, there is the possibility, or at least most of us are, there is the possibility for follow-ons and future conversations. So I really want to throw that out there. I also really want to thank everyone that presented today for going through with the technology and doing an absolutely fabulous job. I'm impressed with all of your presentation skills. So I've learned a few tricks from what not to do from watching all of you. So thank you. It's been it can be a little bit of a struggle, but I think we've managed to go through it just fine. And it's been a success. Is there any last minute things that anybody from the host team would like to conclude on before we sign off?
I just wanted to let people know that there's a lot more people on the Stanford team who have other really interesting projects that they're working on. So I think stay tuned for possibly a future symposium that will showcase these new applications, hopefully showcase the new user interface. And I see in the chat box, there's a question from Catherine about, or from, yeah, who did it? Oh, Hanson asked about a link to the Zoom video to share with colleagues. So I'm sure we'll have that available for participants at some point or whatever. So
yes, definitely, that will be coming out at a future date. It probably won't be this week though, just a heads up, but I definitely have everyone's contact information and we'll be making this available. And there is an intention to publish this on the SPIN website, the Stanford, or there's Software Preservation Network, sorry. My apologies. Well, great. Well, thank you, everyone. I really appreciate, we've just scratched the surface. So thank you very much for your time. Thanks for taking the time to look at our use cases and for your questions. And we'll be in touch and we'll look out for the follow-up survey that'll be coming out tomorrow. So thanks, everyone.
Thank you, Michael.
Thank you. Bye.
Thanks.
Thank you.
Great job, Michael.
Wonderful job. Oh, thank you so much.
Bye, everyone.
Bye.
Thank you so much.
Thanks, Michael.
Good job, everybody. Well done.
thank you, Michael. That
Yeah,
was
thanks,
really
Michael.
well done. Now we can all get some sleep.
Yes.
Jasmine, I sent you a chat.
Yeah, I just now saw that. I keep hearing that.